시작은 늘 설레게 하지. 모든 걸 이겨낼 것처럼 시간을 뒤쫓는 시계바늘처럼 앞질러 가고 싶어.
Today I'm going to present about magnetic flux, Faraday's law, and Lenz's law. There are two formulas in the magnetic flux. First is magnetic flux is equal to Vn cos theta, and magnetic flux linkage is equal to Vn cos theta. The magnetic flux linkage is used when there is a coil with electrons. Besides that, Faraday's law states that when the magnetic flux link with the conductor changes, an EMF is directly proportional to the rate of change of magnetic flux is induced. And the Lenz's law states that the direction of induced current is such that it produces a magnetic field to oppose the change in magnetic flux that induced in the current. And when we combine the Faraday's law and Lenz's law, we will get an expression which is induced EMF equal to negative rate of change of magnetic flux. Thank you.
더 담담해질 테니 다시 시작해.
Good morning to teacher and fellow friends. Tonight I want to present the induced EMF. The unit of the induced EMF is the voltage E. The separate to linear conductor and rotating coil. The linear conductor, by principle of conservation of energy, the work done in moving conductor will convert to the electrical energy. So, by using the Faraday's law, find equal to the magnetic flux times area, cross-sectional area, the induced EMF will be the ELV sin theta. Magnetic flux times length and the velocity. The magnetic flux density V will equal to induced EMF in linear conductor of unit length, unit width, unit length, unit velocity, and right angles. V equal to E over L. About the rotating coil, the magnetic flux link with coil will be the phi equals to MBA cos omega t. Omega will be the angular velocity. By using this equation, we will get the induced EMF will be the MBA omega sin omega t. And also can express as E naught sin omega t. E naught will be the quick induced EMF. So this is the graph of the induced EMF. Thank you.
그 선을 먼저 넘지 말라고. I can fly the sky.
Good morning, teacher and fellow friends. Today we'll be learning about self-induction in the topic of electromagnetic induction. First, the magnetic flux linkage is directly proportional with the current. So we can make it into this formula, which is magnetic flux linkage is equals to L, which is self-induction, times current, which is I. So we should remember this formula at first, and then we will go to the Faraday's law. As we know, the Faraday's law and Lenz's law states that electromagnetic induction is directly proportional to rate of change of magnetic flux, and there should be a negative in front because the direction of the electromagnetic induction is opposite to the changes of magnetic flux. So the formula we get from above we should substitute inside, where we get E is equals to negative d Li over dt, whereas the E is back EMF, the L is self-induction of the coil, and the phi is magnetic flux linkage. And then there is a self-induction in solenoid. First, it's given that the magnetic flux density of solenoid, which is epsilon 0 and I. The N is also N is the number of turns per unit volume, which is we can calculate this as N number of turns, the total number of turns per the volume, the length of the solenoid. So when you substitute the formula here, and then this B, which is magnetic flux density, we should substitute inside this formula, which is the formula for magnetic flux linkage, NPA. When you substitute it, the magnetic flux linkage is also equal to Li, which we got from this formula. So at last we can get the self-induction, which is L is equals to epsilon 0 n square L pi A square. So this is the formula for the self-induction in solenoid. At last, the back EMF in armature coil of motor, the formula is given by electromagnetic, the back EMF is equal to V minus IR, where the V is the potential difference in the motor, I is the current, and R is the resistance. Thank you.
까지 어떤 이유도 어떤 변명도.
So this is the last part of the electromagnetic induction, which is mutual induction. Mutual means same. Therefore, mutual induction is a phenomenon where EMF is induced in a conductor when current at the neighboring conductor is changing. Now let's look at this picture. Let's say we have a solenoid P and solenoid Q. This Q is the neighboring conductor and this P is a conductor. So when the current in the P is changing by changing the resistance inside this circuit by adjusting the rheostat, whether the current will increase or decrease, it will affect the neighboring solenoid by changing the magnetic flux linkage. After that, we move on with this formula. How to calculate the EMF produced by the mutual induction is by using this formula. E equals to negative M, which is a mutual induction, times the rate of change of current. After that, in order to get this mutual induction, we use this formula. U0 times the number of turns of the first solenoid times the number of turns of the second solenoid times with the cross-sectional area and divide by the length of the solenoid, the first solenoid. Then we move on to the last part, which is the application of the mutual induction in our real life. That is transformer, as we know. In order to find the formula to solve the transformer questions, usually we use this formula. Potential difference 1 divided by potential difference of the second solenoid equals to the number of turns of the first solenoid over number of turns of the second solenoid. That's all. Thank you.